So, good morning to all of you. Uh, so, in this magnetism, today we have some discussion on rare earth garnet. Uh, in addition to the spinel structures, there are others oxide, other crystal structures containing transitions or rare earth metals have interesting properties. Particularly today, we discuss with this garnet say structure. What is garnet and what is its structure? So let me write over here. It is also called a rare earth garnet, rare earth garnet, rare earth garnet. The rare earth garnet have general formula. Let me first write the general formula for this rare earth garnet. So M3 C, then Fe2 here A, and then Fe3 D O 12. Okay. uh, O 12. So here this M stands for rare earth ions, rare earth ion. Okay, or yttrium ion. Clear? So this C actually C or A or D, it is actually lattice sites. When there is say close packing of say oxygen ions, then there are interstitial voids that may be tetrahedral, may be octahedral, may be dodecahedral. So these actually interstitial, they represent these voids. C actually represent the dodecahedral voids or interstitial sites, where A represent this octahedral voids or sites, and D represent this say tetrahedral interstices or voids that arises due to cubic close packing of oxygen anions. Clear? So rare earth ion or yttrium actually in structure, they actually fill in dodecahedral voids. There are total say Fe 5 atoms. So out of 5, 2 Fe actually will sit at this say octahedral voids, and 3 will sit at this say tetrahedral voids. But if we explore this uh, for unit cell, actually according to this formula what I have explained, but anything you have to explain based on the unit cell geometry. So there are actually 8 formula units for this particular type of materials. This is one formula, so there is actually 8 formula unit per unit cell. So let me write over here 8 formula units per unit cell. So there will be actually total, if you see, so that is 8 and 3 Fe2 Fe 3 4 12. So total atoms will be M will be 24, Fe, which is actually tetrahedrally coordinated, there will be 60 octahedrally coordinated. Let me write over here O. This will be 16, and this is tetrahedrally. Then there are, say, tetrahedrally coordinated irons will be uh, 24, and then total oxygen ion will be 96. So if we add this, then total you will get 2, 9 to 11 to 13, 15, 16. So per unit cell there these atoms are ions. So there are actually 160 atoms, yeah, ions per unit cell. It is very easy calculations. This formula actually contain 8 times in unit cell. So there will be 160 atoms are ion per unit cell for this garnet structure. You can easily calculate this. Already I told you that M stands for rare earth ion or yttrium ion. So they will actually occupy at dodecahedral wires. This will go to the octahedral wires, the or sides, and this will be the tetrahedral, say, wires. And oxygen, there is a cubic close packing of oxygen ions. So it is very easy to explain the structure. So let me write here structures. All information you have gathered. So just you have to write each and every steps. There are 8 formula units per unit cell. Clear? That is what is meaning of this. I already explained this. So there will be 24 rare earth or yttrium ion, and that will actually filled by this dodecahedral wires. They are dodecahedrally coordinated. There are 16 Fe in 3 plus state. They are octahedrally actually coordinated, and there are, say, this 23 Fe in 3 plus state. They are tetrahedrally coordinated, and oxygen actually will generate, give you CC packing, cubic close packing is generated through this oxygen ions. Clear? Now how you will say calculate the net magnetic moment. So net magnetic moment, let me write over here, net, let me the mu c is the magnetic moment that is due to rare earth ion or yttrium ion. So you have to just minus, and then there will be d side tetrahedrally actually iron 3 plus state minus 2 mu a. So tetrahedrally and octahedrally coordinated iron ions, clear, they will actually align in anti-parallel fashion, so their movement will be subtracted. Clear? And from this moment, if we subtract the total magnetic moment to this difference, then finally what we get, 3 mu c minus 5 mu b, because this will give you mu b, this will actually give you 5 mu b. one say iron in 3 plus state, and there are 5 say uncancelled say electron say spin vector, and each corresponding to one Bohr magneton. So there are 5 actually uh, unpaired electrons, so there will be 5 mu b. This is actually Bohr magneton. So if you subtract 5 Bohr magneton from the net magnetic moment of say dodecahedrally coordinated rare earth ion or yttrium ion, finally this will give you the net magnetic moment. So I hope you are able to understand the structure and how net magnetic moment arises for this formula unit. Actually this is for formula unit. Clear? Now you have to multiply by 8, then you will have magnetic moment for unit cell. So with this we end this, and I hope that you understand the structure and net magnetic moment calculation for rare earth ions. Thank you.